Suppose we have a regular bowl of cereal and a bowl of cereal that loops and loops and loops and keeps looping infinitely. Can a program differentiate between the two? This might seem like a trivial task at the surface, but at its core lies one of the most important concepts of computability theory. For example, we have a program that infinitely prints croissant and a program that halts after printing croissant. Now the question is, can we create a machine, the decider, which takes in such a program and an input to that program and tells us whether that program halts or loops infinitely? Determining exactly this, if a program halts or loops given a specific input, is known as the halting problem. And as proved by Alan Turing in 1936, the halting problem is so hard to solve that it is undecidable. Undecidable is just a fancy, computer sciencey way of saying that it is logically impossible to find a solution. Let's take a look at why this is so. To prove the undecidability of the halting problem, we will need to use the process of proof by contradiction. Proof by contradiction is a method of proof that establishes the truth of the proposition by showing that assuming the proposition to be false leads to a contradiction. For this proof, we will assume for the sake of contradiction that such a magical being exists that can solve the halting problem. This being, in our case, will be a clairvoyant, who is 100% accurate with her predictions. Let's call her Claire. We introduce another being in this system, the Joker, who takes a program P and asks Claire if P halts or loops with P itself as input. Now the funny thing with the Joker is that when Claire decides that P loops, the Joker halts. And when Claire decides that P halts, the Joker loops. This behavior of our system leads us to an interesting question. Does the Joker given itself as input halt or loop? Let's say that Claire decides that the Joker loops, but the Joker remaining true to his programming actually halts in this case. Alternatively, let's say Claire decides that the Joker halts. The Joker, being the maniac he is, actually loops in this case. How curious. At the beginning, we assumed that Claire was 100% accurate. However, she fails to predict the Joker's behavior accurately. Turns out, Claire is a fraud. We have arrived at a contradiction. This means that our original assumption of the existence of a magical being that could solve the halting problem was in fact false. Consequently, we can conclude that the halting problem is indeed undecidable.